Dude the Builder here, and in this episode of Zig and Death we're going to be taking a look at the build system again, but this time we're going to be generating some Zig code with the build system, and we'll be using that generated Zig code in our main application, and also we're going to see how we can pass some arguments in this code generation process. So there's quite a few steps that we have to cover. So let's dive right in. Here we are looking at the build.zig for a new project. I basically just removed the comments and added the parts needed so we can do some code generation. The first thing that we want to take a look at, and this is not necessarily required for code generation, this is just to demonstrate how, as part of the code generation, we can have build time options that we can then use in the code generation process. Here, we're defining an option and we're assigning it to this fib end constant. And what we're going to be doing, we're going to be using once again the Fibonacci function, and we want to specify the limit of the sequence of Fibonacci numbers that we want to generate. And with this option, basically the user with the -d flag to Zig build can specify that number. Okay, here we're not actually using a numeric type for this option. We're using a string, as you can see here, a slice of const u8. We could use a numeric type, but when we see below, we're going to be passing this as an argument to our code generation program executable, and these arguments have to be strings. So that's why we are then accepting this option as a string, so we don't have to convert it from a number to a string. We'll do the conversion from the string to a number in our generation program. Next up, we have the actual step for building the code generation program. And this can get a little confusing because we are building here in this step the program that's going to build, that's going to generate the Zig code that we're then going to use as part of the normal build process. So this is basically the code generation executable. That's why we call it here gen.exe. And that Zig, the code for this code generation is located in our source directory and in a file called gen.zig. We'll be looking at that further down. And basically, aside from that, we have the normal options that we usually use when we add an executable to the build process. Next up, we're going to be defining the actual step that runs that code generation executable. And we're basically here with add run artifact. We are telling the build system that we want to run this gen.exe executable that we have defined here, and we are specifying that this run step will depend on that gen.exe step, which means that you have to build the gen.exe executable before you can run it. So that's basically intuitive. Next up, we have basically one of the most important parts of this code generation process. We're going to be passing in what's called an output file arg. We're using here for the run gen.exe step, we're adding the output file arg named file fibs.zig, and the result of this call, we are assigning it to this constant called output file. And we're doing a couple of important things here. With the add output file arg call here, we are adding an argument that's going to be passed by the build system to our code generation executable when it's run. And it's like if you pass the command line argument to that program, and the value of that argument is going to be fibs.zig, this string here. But also, aside from that, since it's an output file arg, we're also telling the build system that this program is going to be generating a file, and this is going to be the name, fibs.zig. And the build system will then take that generated file and write it to its cache directory structure. And it'll then keep track of that file as part of the caching system of the build system. So if any type of change requires this file to be regenerated or recopied to its final destination, the build system will take care of keeping track of that. And that's the really powerful part of this. Because if you think about it, you could write a normal Zig program that generates code and writes it out to a file and puts it wherever you want. But then you wouldn't have the advantage of the build system keeping track of the status of that file and keeping a cache version. So this is a really powerful feature of the build system when it comes to code generation, taking advantage of the built-in caching system of the build system. So once we do that, we are going to specify, as I mentioned, that option that we defined above, the fib end option to the build, to Zig build. Now we can pass that option to the code generation when it's going to execute as a command line option. And this time it's just a normal argument, so it'll be add arg. The difference here, output file arg has all those other implications about the build system and generating an output file. But add arg just simply creates a command line argument that's going to be passed to that running executable. And we're going to be passing in the value of fib end. Then what we have here is that once we generate that Zig code file, we will want to write it out to its final destination. This is done basically here with this add write files. What this will do, this allows the build process to write files to different places. In this case, we want to be writing our final file is going to be in our source directory. And we're going to be doing that by calling this method on this write files object, the copy file to source. And as you can see, we're using that output file constant that we obtained when we added the output file argument to our code generation step. And we're specifying that the final destination is going to be src fibs.zig. So when we specified here fibs.zig, this is basically the file that's generated and placed in the cache system of the build system. And when we specify here src builds fibs.zig, this is the final version of that generated file. So the build system will basically copy the cache version from the cache to src / fibs.zig if it's necessary. Now we have our normal main application executable as you would find in any build.zig file. Okay, and here an important aspect of this process is that we're specifying here that the main exe step depends on the gen write files step. Okay, so basically this says to the build system, we can't run the main application without first running the code gen and writing out the file. And we have to specify this explicitly because if we don't, the build system can generate independent steps in parallel. Okay, but since we're specifying that this one depends on the other one, then it'll first have to run those other steps before running this step. Then we have this install artifact, as we usually do, which will actually write out the main exe to zigout bin. We don't do this for the code generation executable because we only need that code generation executable as part of the build process. We don't need it as a final product. What we do need as a final product is our main program. So we specify it here with install artifact. And then finally, we have the convenience step to be able to run with the zig build run that main program. As usual, this is what you normally see in a build.zig. Okay. And with that, we have the end of the build.zig. Now, if we go to our main.zig file, you're going to see here that we are importing from a file called fibs.zig. So fibs.zig is expected to be in our source directory. And in that file, we're importing this identifier called fibs, which is going to be an array of numbers of the Fibonacci sequence up to that option that we specified, the fib end. And as it says here in the comment, the build system, since we specified that our main application depends on the generation and the writing of the generated files, this is guaranteed to be available when we're going to build this main application. This import will always work because this fibs.zig is going to be in our source directory already generated. And once we have that, we simply use a for loop to print out that sequence. Now let's take a look at that gen.zig. This is our code generation. This is a normal zig program. What we're going to be doing here is we're going to be using, since I'm on a Unix-like system, I'm going to be using stud process args without any allocator for the command line arguments. We're going to skip the first argument, which is the name of the running program. And then the next argument is going to be that file name that's going to be passed in by the build system thanks to that add output file arg call. Okay, so this file name argument should be that fibs.zig string that we passed in to the build system. And the important part about this is that here, when we're going to be creating this file and writing the content to that file, it's going to be actually written in the Zig build system cache directory structure. And Zig build will take care of keeping track if that we need to regenerate that file if any type of change requires that. We're going to see examples of that when we run the actual build. So basically here, we create a file. We make sure to close it when we're finished. We create a buffered writer for performance reasons. And we obtain the actual writer from the buffered writer. Then we're going to be printing out what's going to be at the beginning of our file, the head of that file, which is basically static. Just defining here the definition of this constant fibs, and the type, it's going to be an array of usize. And we write that with write all to the file. The write all call is more efficient than print, because print has to deal with the format string and dealing with the placeholders and all that. Write all basically just writes the bytes that you pass to the writer. Here is when we're going to access that second argument that we're passing in from the build system, which is just the string of that number that we want to be the limit of the Fibonacci sequence. And we're going to be using parse int from studfunct to parse that string as a usize. Okay, and we're using base 10. We're assigning it here to this constant n. And then we're going to use a for loop to iterate from 0 to that limit. And we're going to be printing, or basically writing to that file using print here, the print method. the result of calling our fib function with each one of the indices of the iteration. Okay. And then finally, we have the tail of that file, which is another constant here, and we write it out with write all. And finally, really important when we're using a buffered writer is to flush. If you don't flush at the end, you could get an incomplete file. Okay. And here we have our traditional Fibonacci function. So let's move over to the terminal now. Let's see our current project status. We just have the build.zig and our src folder. Inside that source folder, we just have the gen.zig and the main.zig. So now we can run the zig build -- summary all. And that completed successfully. And this summary is really interesting, because here you can see all of those steps required to complete this build process as we have specified in the build.zig. We have first down here the generation of genext, which is building that executable. Then we have the actual running of that genext executable here, as you can see. And here we have the write files. So basically this is writing out that src fibs.zig file. Here we're building our main application. And then we install it, install main, because that's the only one we're going to be installing. And that's basically it for the build. That means that now we can run here our zig out bin, and we have here our main, and there you go. We have the Fibonacci numbers from 1 to 7 here. Now, if we take a look at that fibs.zig, which was generated, as you can see, we have here the generated code. This array of numbers from the Fibonacci sequence was generated at build time, so it's made available at build time for our main.zig file. Now, if we were to, let's edit that file. Let's say that we add here a 100. We write our changes. Let's make sure, there we go, we have that 100. But if we run our program, you're going to see that that change is not reflected, because we would have to build the program once again. And if we indeed build once again, we're going to see that practically all of these steps, they say that they were cached. Okay. And now, if we look at that fibs.zig, we're going to see that the edit that we did directly in the file is gone. And this is basically that build system caching that I mentioned. The build system will check that the cache version is different from the version in our source folder, and then it will copy the cache version to that source folder. And it's important to note that since the actual genext source didn't change, the build system is smart enough. It knows it doesn't have to rebuild our genext, and it doesn't have to run it again to generate this file. It just uses the cached version of this file to copy it again to our source folder. Okay. And for example, if I remove that fibs.zig, and then we build again, and then I try to read it, there it is again. Once again, the build system takes care of that. And now if I run our program, there we have the output. Now let's do a zig build, and let's pass in that option fib end equals 10. This is a build time option, that's going to be passed into our code generation exe. And now if we run that program once again, we're going to see that now we have the sequence up to 10. And if we see the contents of the generated file, we have the additional numbers in the sequence. So as you can see, this code generation using the Zig build system is indeed a really powerful feature of the build system. The way the build system is taking shape is that it will be a really kind of Swiss Army knife of anything that you need at build time. You can do it, and you can do it with Zig without having to learn any other language or any other build system, like the case with other languages. It's all Zig. So I hope you find this useful. Dude the Builder here. I'll see you in the next one.